We're going to talk today about exponential equations. So in a linear equation, we are just adding the same number over and over and over. So if I have the slope-intercept equation of y equals 2x plus 1, how would you describe what's happening in that equation? How would we graph that? Remember how to do that? So the y-intercept is 1, and then the slope is up 2 over 1. Up 2 over 1. So you could describe that equation by saying you have $1 in your bank account and your parents pay you $2 every week. Wouldn't that be nice? So in a linear equation, we are keeping the increase constant. We're going up 2 every time period. Or it could be going down. It could be going down 3 every time period. Or you could even go up 2 over 3, up 2 over 3. But it's the same number over and over and over. And we're adding. An exponential equation is the same idea, but instead of adding, we're going to multiply. Okay? So an exponential equation would look something like this. That would be 2 to the x. And if you look at this in a table, so if this is x and this is 2 to the x, if I plug in 0, what do I get? 1. What if I plug in 1? I get 2. What if I plug in 2? 2 times 2 would be 4. What if I plug in 3? Not 6. So what's the pattern from here to here? Times 2. What's the pattern from here to here? Times 2. So this one should be 8, and 4 would be 16, and 5 would be 32. So we're doing the same thing over and over and over, but this time instead of adding or subtracting, we're multiplying. So that x value just tells us how many 2's. What? Oh, good. So what if I wanted to do y equals 2 to the x, and I wanted to plug in x equals 10? Can I jump straight to 10, or do I have to go down this list? How would I go straight to 10? I would just type in my calculator, 2 to the 10th, and this is going to be a really big number, 1024. So 2 to the 10th is 1024. Everybody get that? Okay. We could do the same thing with 3's. What if I had x and 3 to the x? 0 is still going to be 1. What happens when I plug in 1? Hey, I'm losing some of you. Pay attention. So if I plug in 2, 9. If I plugged in 3, 27. If I skipped all the way down to 15, all I have to do is type in 3 to the 15th, and I get 1,434,008. Oh no, 34,000. I lied. That's 14 million. I get 14 million. So exponential equations can grow very, very fast. Linear equations, the growth or the decay is always the same. We're always going up by the same number, and we're always going down by the same number. In exponential equations, we're always multiplying by the same number. So eventually, the numbers are going to get really, really large, or in some cases, really, really small. So what if I had a third exponential equation, and it was y equals 1/2 to the x? So if I have x and 1/2 to the x, what happens when I plug in 0? I get 1. What happens when I plug in 2? That would be 1/2 times 1/2, which would be 1 times 1 on the top, and 2 times 2, or sorry, this would be 1/2, I'm sorry, and 2 would be 1/4. Do you guys get that? You multiply the numerators together, and you multiply the denominators together. What about 3? Not 6. It would be 2 times 2 times 2 in the denominator. 1/8. Do you notice a pattern? Is it similar to something else? It's the same as this one, except it's upside down. So what would x equals 4 give me? 1/16. And x equals 5 would be 1/32. What's happening to those numbers? They're getting smaller. What else do you notice? They are getting smaller. Are they getting smaller faster? Are we approaching something? What happens when you keep making numbers smaller and smaller and smaller and smaller? They get close. They actually do get closer together, that's true. But they also get closer to another number. 0. Right? These numbers are getting closer and closer to 0. So if I go into my y equals, actually, why don't you do this? I want you to graph 2 raised to the x. And then how would I type in 1/2 raised to the x? I need to put it in parentheses. So graph 2 to the x and graph 1/2 to the x. And then go to the table. So if we look at our table, my blue values are the 2 to the x equation. And you notice they're getting bigger. And if I were to scroll down, they start getting really big really fast. And what do you notice about the red numbers? They get smaller. That bottom one says 9.8 e negative 4. What does that mean? That is scientific notation, and it's telling me that that decimal is so small it doesn't really fit on the screen. So it's going to change it to scientific notation. This e negative 4 tells me to move this 4 places. So it's actually 0.0009. Does everybody understand that? If you have an e to a negative, you move the decimal to the left, because negative is left, right? Negative is left, correct? So if we scroll down a little bit, you'll start to notice that they get even smaller. So we're at e negative 4, e negative 5, e negative 6, and now the blue numbers start having e's. So on 22, I have 4.19 e to the 6th. What does that mean? We need to move the decimal right 6 places. So e to a positive number is a very big number. E to a negative number is a very small number. So my blue equation is getting bigger, so big the calculator can't fit it. And then the red equation is getting small, so small the calculator can't fit it. Okay? Where is my blue equation heading? As it gets bigger, where are we heading towards? We're going up, so we're heading towards infinity. Good. Where is the red equation going toward? It's not going toward negative infinity because it's never going to cross 0. It's actually heading to 0. So when you look at a linear equation, you have something like this that is a positive slope, or you could have something like this, which is a negative slope, right? But the slope never changes. Because it's a straight line, it's the same slope over and over and over. But exponential equations don't work that way. They're either getting bigger and bigger and bigger and bigger, each slope is a little bit steeper, or the slope is becoming a little less steep. So exponential equations will either look like this, which is going up, or this, which is going down. Okay? If you have an exponential equation, yes. No. Exponential equations, unless you shift it, right? You could, so she asked, will exponential equations ever touch 0? So that will never touch 0. But if you say subtract 3, then you'd go down 1, 2, 3, and then they would. But a pure exponential equation will never touch the x-axis. So if you have an exponential equation that's going up, we call that growth. If you have an exponential equation that's going down, we call that decay. And if you push graph, you should see that. So here's my exponential growth, and here is the exponential decay. There it is. What do you notice about those two graphs? They're exactly the same, and invert is not quite the true word, and you don't know that yet, but it's actually a reflection. It's a reflection across the y-axis. So timesing by 2 is the opposite of dividing by 2. Okay? If we go back to our original equations, what is it about this that causes the graph to go up? And what is it about this that causes the graph to go down? Any idea? Why did these numbers get bigger and these numbers got smaller? Because this is kind of an important part of exponential equations. Why are some of them going up and some of them going down? Okay? So multiplying by 2 makes numbers bigger, and multiplying by 1/2 makes numbers smaller. Could we come up with a rule and say these numbers are going to make exponential equations go up, and these numbers are going to make exponential equations go down? So it has something to do with this. When will exponential equations go up, and when will exponential equations go down? Good. If they're less than 1, or we would call those fractions, right? Now, that's not totally true, because 5 over 4, is that a fraction? Yes, but it's bigger than 1. It's an improper fraction, which is kind of sad. What could 5 over 4 ever do to be improper? I don't know. But yeah, improper fractions, sometimes we don't call them fractions. But if your multiplication number is less than 1, then we're going to be going down. Does everybody understand that? And if your multiplication number is greater than 1, then we're going to go up. Is it possible to graph an exponential equation that doesn't go up or down? What would you multiply by so you didn't go up or down? Not 0, 1. So let's graph. Go into y equals. Down on y3, let's graph 1 raised to the x and see what it looks like. 1 raised to the x did not go up or down. In fact, that's just a line, because 1 times 1 is always 1, no matter what number you plug in. Okay, so if I had y equals 3 to the x and y equals 5 to the x, and y equals 1/4 to the x, and y equals 1/10 to the x. What can you tell me about those four equations? What do you know about those four equations? Can you tell me anything about their directions? So, what's happening here? This one is going up. Okay, the next one is going up. The next one, down. And the next one, down. Okay, so I'm going to call this y1, y2, y3, and y4. So if I graph y1, it's going to go up. And what happens when I plug in x equals 0? I get 1. So all of these graphs hit the y-axis at 1. So here's my 1. y1 is growing. How does y2 compare to y1? It's also growing, but it's growing faster. So y2 is going to start in the same place and just be steeper. But what's going to happen if we go backwards? Is it going to be above y1 or below y1? So if we go back 3 years into the past and we're multiplying by 3, then the y2 graph is going to be underneath the y1 graph. They're going to cross at 0, and then y2 is going to be taller. So it's going to look something like this. Do you see that? On the right side, y2 is higher because it's growing faster. But if we look on the left, y1 is higher because y2 is shrinking faster. Does that make sense? So if we go forward in time, y2 is growing faster. But if we go backwards in time, y2 is shrinking faster. Does that make sense? Okay. What about y3? What's happening in y3? Is it going up or down? Down. So we're going to start up high, and this will be y3. How does y4 compare to y3? It's shrinking faster. So I'm going to start at the same point, and I'm going to go down faster. Well, what's going to happen if I look backwards? It's going to be higher. Does that make sense? Okay. Now notice, every graph either has this shape or this shape. Okay. On the test, in this class, a lot of kids try to graph things like this. That's the wrong shape. Okay. It has to get close to the x-axis but never touch it. And then you just have to decide, is it going up or is it going down? So open your student journals. What are we on? 1.6. And turn to this page. We need to match equations to graphs. So let's go through all of the equations. So letter A, which direction are we going? So A is going up, B, up, C, up, D, down, E, down, F, down. What if I had f of x equals 5/4 raised to the x? What way is that going? up. Is it going up very fast? No, it's just a little bit above 1. It's going up very, very slowly. All right. Now, if we look at all of the up graphs, A through C, what can you tell me about those three compared to each other? What's that? Which one's the fastest? C is the fastest because we're multiplying by 4. Which one's the slowest? A. So B would be in the middle. If you look at capital A through E, which three graphs are going up? A, C, and F. All right. Which one is going up the fastest? C is. Does everybody get that? C is going up the fastest, so that must be C, little c. Okay. Which one's going up the slowest? A. So this is little a, and then F is in the middle, so that would be letter B. Do you guys get that? Okay. Of the equations, little d through little f, which equation is dropping the fastest? E is the fastest. Why? It has the smallest fraction. 1/4 is smaller than 1/2 or 1/3. Everybody get that? Okay. So which graph is shrinking the fastest? Which one's going down the fastest? Which one's the steepest? If it were a roller coaster, which one do you want to ride? E. Because you can see up here at the top, you can kind of tell how fast they're dropping. So E is dropping the fastest. So that would be letter F. Okay, and which one's dropping the slowest? D. And then B is going to be in the middle, so that would be E. Do those make sense? You guys understand that? Okay. Okay, that's going to take us through the first set. All right, we don't want to do recursive. We don't want to do recursive. Okay, we are going to do 1.6, 1 through 23 all. And then 75 to 82 all. So 1.6, 1 through 23 all, and then there's that review section at the back, 75 to 82 all. All right. Good luck.